Okay, hello. Uh, this topic's called large sample tests. Basically, because you're using the central limit theorem, which requires that you have a reasonably large sample. Well, it doesn't have to be too large, but uh, it's using the approximation that the sample mean is approximately normal for n sufficiently large. So this is all, it will sort of review the tests idea and you'll see how it's used. So this is a very common way to use hypothesis tests, and yeah, it seems pretty powerful because you don't really need to know too much about the underlying sample. You just assume independence, and then you can claim a normal distribution for the sample mean, and that allows you to make inference about the expected value of one outcome. So tests are often made when sample is large enough, so the central limit theorem implies that the sample mean is approximately normal. In this case, we might be interested in testing whether the expected value of an outcome mu is in a certain range. Let's just jump to an example. This will, like I said, part of the purpose of this too is to just do more examples of hypothesis tests before we get to the theoretical stuff. So suppose a tire company claims the average highway lifetime of one tire, a single tire, is 20,000 miles. So company claims average lifetime, expected lifetime of their tire is 20,000 miles. Okay, a sample is taken. Of size 60 is taken, and the sample mean and sample variance are, and we have y bar was equal to, say, 19,250, not bad, a little lower than their claim, and the sample variance S squared is 1,000,000. So 10 to the 6, say. So the sample standard deviation is 1,000. Okay? Let me make it so you can see it. That might be more helpful. Okay, so is there evidence to refute the company's claim? So does there exist? Is there evidence to refute the claim? Some might argue already there is, since it's lower, but really there's some natural statistical variation. They did not claim there wasn't. They said on the average, it should be 20,000. They didn't say on the average for this particular batch of 60. They mean on the average, asymptotically, if you took all of them. So let's say use a test. So this should put question mark, use a test with a bound for the probability of type 1 error equal to, say, 0.05, which is pretty standard. Okay, so we need to come up with test statistic, rejection region, and of course the null and alternative hypothesis. So remember, we want to try to reject the claim. We're going to say, well, we want to start with the claim, and we don't want to be like a nasty person and say they're wrong and then make them prove they're right. We're going to say, okay, suppose they're right. Do we have enough information to reject the claim? So the null hypothesis, which will include the equal sign, will be mu is greater than, we'll give them the benefit of the doubt, greater than 20,000. And the alternative hypothesis will be no, mu is less than, and not equal to, but less than 20,000, okay? Our test stat, well, we don't have a lot to work with. It's already been boiled down, and I think we want to use this. So our test statistic, so y bar is test stat, it's called. And the rejection region, RR, will be y bar less than k. Okay, now, I haven't told you anything. The whole thing now is to determine k, right? Whole thing is to determine k. So, how do you determine k? It's based on the significance level you want, how you want to bound the probability of type 1 error. So, to determine k, that should be the next sentence we write. So, to choose k, note, we want we want alpha to be less than or equal to 0.05, okay, or equal to 0.05 at the worst. So we have probability, choose HA given H0 is true. This is less than the probability choose less than or equal to choose HA given mu equals 20,000. Because if it's more than 20,000, if mu is more than 20,000, the probability we'll choose HA will go down. So it's the highest at the boundary here. Okay, so this is the probability of the type 1 error. This is alpha. Okay, so I put period here. So we have probability, choose H, so this is equal to alpha. This is less than or equal to this. Okay, and this is equal to, well, what's the probability we choose HA? This is the probability that y bar is less than k, given mu equals 20,000. Now, y bar is approximately normal by the central limit theorem. Normal with mean, well, given mu is equal to 20,000. So this is with y bar with given mu equals 20,000, just to be clear, is normal. Mean is 20,000. And variance is variance of y bar should be sigma squared over n, right? So we have 10 to the 6th, so 10 to the 6th over 60, whatever that is, 10 to the 5th over 6, okay? Yep, okay, right? Sigma squared over n, mu. All right, so probability, so alpha, probability choose HA given H0 is less than or equal to probability y bar is less than k when y bar is distributed this way. So let's make this into a standard normal. So this is the probability z is less than k minus 20,000 divided by the square root of this, right? The square root of this. So that gives me 1,000 in the denominator, and square root of 60 can fly up here, right? Okay, where? Oh my God, not writing a thing. So sorry. So y bar is approximately this. So the probability we choose HA given H0 is the probability y bar is less than that given that. So I'm just going to transform. I'm assuming it's normal, so I can make this linear transformation on y bar to z by subtracting 20,000 and dividing by the square root of this, which I just did here. So z is normal 0, 1. Okay. Now, we want this to be, since we want this to be 0.05, what does this tell us? Okay. What does this tell us? So, and by the way, too, here, we also use S squared is approximation for sigma squared here, right? Okay, so if we're here now, we want this to be, look, this is going to be negative. So I want this to be Q norm of something, right? So we want, so for alpha less than 0.05, we want this to be Q norm of 0.05. So we want K minus 20,000 over 1,000 square root 60 equal to Q norm 0.05, which is equal to minus 1.645. Okay, here's Q norm. So there's that, minus 1.645. And over here, I just have areas 0.05 in here, 0.95. Okay? All right, so I need that so I can solve for K. So solve for K. I solve for K. And we get K equals 19,788. That's what I get. Okay, I'm just solving this equation. So this test will give me the test I want with the alpha equal 0.05. So let's write that down. So test should be, see the pattern is I write the form y bar less than k. I know which direction I want to go to, but you know, you have to do some calculations to actually find k based on alpha that's given. So test should be RR equals, test is completely specified by this, right? Y bar less than 19,788. So that's the rejection region. Since y bar in our example is equal to 19,250, we do reject H0, company's claim that average lifetime is 20,000 miles. Okay. All right. All right. I think, yeah, that's long enough for this video. I'll stop and we'll talk about, we'll do another example and then talk about p-value too. For what does p-value mean? Okay. That's coming in the very next lecture. Take care. Click on the next lecture.